Hey everybody, welcome to Introduction to Computers and Programming. This is Katie Vandermeer and I am going to talk to you briefly about Chapter 1. It's a great chapter, but it's the beginning of the book, and we don't do a ton of hands-on in this, so we're going to get through the material and just talk about some of the key words. Now, I love this textbook because it talks about computer programming, logic, and design without throwing in specifics of a particular language. So you don't have to know Java or C# or C++ or Visual Basic. We're going to learn the structure of programming and then apply it to a tool, a compiler, a real small interpreter called Microsoft Small Basic, and I'll show you real quick how to use that today too in this video. But our next video for this chapter or for the next chapters, we'll do more hands-on. So you have to listen to this because it will help you to read the chapter and help you with the quiz. So I'll keep it short, under 20, I promise. First of all, we use computers. This is general knowledge. We use computers, work, home, school, everything we do, phones, everything is based on a computer, and the way that these devices work or how we interact with them are something called computer programs. So even our smartphones, those apps that we use, those are written in some sort of computer language that a programmer designs. So that's what we're learning in this class, and as you go on with the rest of your education, you'll learn how to do. Computers are designed to do any job that we tell them it to do. So I hear very often in the beginning, my program doesn't work. Well, it does exactly what you tell it to do because you're the boss of that program. So if it doesn't work, it's something that you told it to do wrong. All a program is a set of instructions. So, you know, do A, then do B, then do C, and then end your program. But you tell it what those A, B, C's are. Programs, commonly called software. Programs are program developers, the people who create them. Training and skill to design, create, and test computer programs. Now I did a quick search. Let me go over to my friend Google. I did a quick search on famous computer programmers, and we go back to our very favorite and first woman programmer, Ada Lovelace. So do a quick search and you can see these people. You've heard of some of them, obviously. Facebook, Mark Zuckerberg, Bill Gates from Microsoft, Ken Thompson. He developed the original Unix system or systems, or programmed with crediting that. Linus Torvalds for Linux. These are operating systems or applications or network operating systems, things that we use on our computer. And brilliant and not so brilliant. Some people have developed programs. You don't have to be a genius to be a computer programmer. Grace Hopper developed one of the early programming languages and was one of the most famous women programmers during the war. In the book and in the material that you'll read talks about ENIAC, and this is the first computer program that was the first computer system that was programmable. And if you do a quick image search, you'll look, and all of the, well, here's a couple of men, but most of the people who programmed this ENIAC were women, and that's because it was in the 40s during the war. So men were off to war and women were running the show with programs. So I think that's cool to acknowledge, because one of the things that I'm passionate about is getting women in the field of programming. It's not just a job for men. Obviously, women have a place in this world as well. Steve Wozniak, if you've heard of him, he was fundamental in starting Apple with Steve Jobs, which he's probably on here somewhere. Some of these people I do not know, so if we click on their names, we can probably follow a little bit. Who was that guy? Aaron Swartz. He died young. So, I won't get caught up in what happened to him. I don't know. Let's see, some other famous people. You won't see my name up here. I like programming. This is one of my favorite topics to teach, so I hope as you are listening to my videos and if you're sitting in my face-to-face class, you'll pick that up from me, that programming is very rewarding when you get your program to work. So there's a couple of famous programmers, and some we know and some we don't, and just a quick Google search. One of the other things I want to point out, and then we'll zip through the rest of the PowerPoints real quick, just so you know what's in the book. If you don't read the chapter, then you're listening to this and thumbing through at the same time. One of the sites that I use is code.org, and if you are new to programming and you don't know what computer programming is, we'll learn this in our class, but this is a great site where you can use different tutorials to learn how to code. And Hour of Code is something they do, I think, in November, December. We'll do that this semester. But the studio.code.org, you create an account, it's free, and then it has different age groups. So now I will tell you, see, we could go through any of these, but if you've never coded before, you're going to want to start out in probably course 2. Course 1 is really basic, but even 6 to 18, you could be a 50-year-old person taking this course. If you've never coded before, your level is here, probably course 2. I have, and you've seen this on, let's see, you've seen this in Facebook if you follow me, and then also in my Blackboard course. One of the cool things that I do with this course in my face-to-face course is a service learning project where we go into, let's see if we have it out here on my website. We go into 5th grade classroom in the community, and it's not out there, and we teach them how to use computer or design computer programs through code.org. And I'll do that again this year. It's a service learning project. You have to actually go to the school to teach them how to code, but we do that through code.org. Now I'm zipping through all my Facebook crap when I probably should just go to my YouTube channel. But in Blackboard you can see the videos. I just wanted to give you an idea real quick. Okay, and this is in Blackboard, easier to find. But if you are interested in service learning, let me pause this so it doesn't start playing. Oh, it's got good music, doesn't it? Watch this video. I'll put the link out there too. And this is what we do when we teach our 5th graders to computer program. Part of the service learning aspect is you have a trade-off. So you get a credit on your transcripts that you participated in service learning, and also that you get to skip some of the assignments in this course. So I've offered and explained this to my face-to-face course. I only have room for 5 students. So if there are not enough in my face-to-face course who are able to do that, I'll open it up to online students, and you'll have that opportunity. So if you're interested, send me an email. I won't post anything in the online course unless I'm looking for people specifically, but it's an awesome experience. And I got sidetracked, but this is better than going through a PowerPoint. But we use code.org. So again, if you're struggling at the beginning, like what is programming, how to do it, check out code.org. It's awesome. If you have little children, they can do this. If you have a parent who wants to, who's bored and doesn't know how to code or understand what to do, you can show them this, and even they can do it. So, like my mom can hardly use her cell phone. She's getting better for some things, but the people that you don't think can code, they can learn to code using code.org. One of the other links I'll put next to this video is Code Stars. You have to watch this. It's 10 minutes long. I'll make it a requirement in the class. If you're in face-to-face, we watched it, or we'll watch it in class. But it's an awesome video on what coding is and where coding is used. So that is what computer programming is all about. Now, I'm going to zip through some of these because it's a history lesson and some things that you can read on your own, but I wanted to give you an introduction to the chapter. Hardware and software is explained in here. Hardware, obviously, hopefully you know this, are things like the mouse and the keyboard and printers and hard drives and disk players, memory sticks. Those are hardware that store some sort of data. And then software, see, I will just go through this part fast because you'll read it. I love this picture. Love it, love it, love it. It's from the 40s, of course, during the war, and women being the first programmers. And holds a modern microprocessor. Right there. It's so amazing how much data now, if you think, can be stored in such a little device. Even phones, it's just amazing. I think so. Memory. Well, let me talk briefly about this. When you're a computer programmer, paying attention to how much memory you use is super important, because every time you create a variable in programming, it takes up space. And some of you might not remember blue screen of death, but this is when our Windows systems would just bomb. It still happens. Like, this is Windows 8, it still happens. But way back in the day, you know, when people even just a little older than the traditional student, like myself, I'm not that old, but we had blue screen of death all the time. And the reason for that is people would code a program, they would create all these variables, you know, that take up memory, and then they wouldn't free that memory. Or memory was very limited compared to what it is now on a computer. So everything locked up. Now, if you have a pretty good computer, you can have like 10 windows open. But if you have a game, like if you're on not a gaming computer, but you're running a game and you try to launch Word and you try to run a browser and do a system backup at the same time, all those things are written by programs, and all those things take up memory, and it'll slow down your computer. So that's why memory is important when you're a computer programmer. Even though memory is cheaper nowadays, it's still something that you need to be aware of when you're coding your program. And we'll talk about this when we do chapter 2, I think, which is on variables. Secondary storage devices, memory sticks, external hard drives. Solid state drives are amazing. If you don't have a computer with a solid state drive, your computer seems like a dinosaur because it's so slow. But I love solid state. It boots my laptop like in a second. 2 seconds or 3 seconds. It's just amazing. We've already talked about those. Oh, cloud storage. This is a new place that we learn to interact with as programmers, because we are storing everything nowadays in the cloud. Files at work are in the cloud. Our phone, we're sending pictures up to the cloud. You know that adage, which isn't all that old anymore, about don't put anything on the internet that you wouldn't want your grandma to see. Well, that's because everything is saved, and a lot of those things are saved in the cloud. It's helpful to get stuff back when it's in the cloud, but, you know, some things you don't want back, if you know what I mean. Anyway, cloud data we interact with as well. Input devices, keyboards, mouse, scanners, microphones. I'm talking in a microphone right now. My input from the microphone is going into the computer, and then when you listen to it, it's coming out of the speakers. So you have input and output devices. As programmers, we do input. In this class, we'll do input from the keyboard, and I'll show you that on our first program, and we'll do output to the screen. But there's a lot of input and output devices that we interact with as programmers. You know, I could write a program that takes in data and it prints that data to an Excel database or an Access database or a file. Those are different output mediums. Software definitions are there, some examples. Oh, how computer stores data. I'm not sure on my time, but I'm trying to stick to under 20 minutes. All data is stored in binary, and then this quick section of the chapter talks about how to read binary, but very briefly. We don't have to know this for this course. As you go on into your other computer classes, you'll learn how to convert binary to the numbers or letters to read them. But what you should know is that all data is written in binary and stored in binary in bits and bytes. 8 bits is 1 byte. Storing characters and advanced number storage. We'll talk about this when we talk about our next chapter, but we have integers that we store, which are whole numbers, and then we have real numbers, which are floating point or decimal values. How computer programs work. So we'll learn this pretty quickly, but we basically, after what we'll do in programming is we'll design a program. So our computer is not a brain. It's not smart, even though we think it runs everything, but it only runs those things that a human being has told it to run. So we tell our program or our computer what to do. So we design our program, and here's just an example of of a process that we want. So once we design our program, we give it a set of instructions, and then we put it into a compiler or an interpreter, and it interprets those instructions to an executable. Those are all that this section in 1.4 is talking about. Some high-level languages that you'll learn today, they're not all on this list, and it doesn't include everything on this list, but typically you'll learn Java, C++, C#, Visual Basic. Those are your great foundation languages to learn. Once you learn one language, it's easier to learn the next as well. Keywords, these are things that represent specific meaning to the programming language. Operators are things like additions, equal signs. Syntax is your set of rules, and statements are your lines of code. So those definitions are important. We'll be referring to those often. If you get a syntax error, you have to be able to interpret it. We'll ask you to add these two numbers together using the appropriate operators, so you'll have to know what we're referring to there. And syntax is the rules of the language, so that's the biggest one. Compilers and interpreters, this is where we get to the language where we're going to code our program. So let me finish this up by showing you a quick program, and then I'll be done talking with you for this section. One note though, in DreamSpark you can download visualstudio.net. We will use this at the end of our semester, but it's a huge compiler that costs industry thousands of dollars, and you can get it for free through DreamSpark. So I definitely recommend you download a copy, save it, or install it, and you'll use it in all of your programming classes from here on out. That's visualstudio.net. Okay, I don't want to go through that. We went through the rest of that. I want to show you quickly our interpreter compiler that we're using. So we're using Microsoft Small Basic, and it's very easy to learn, which is why we are using it, so we can focus on the fundamentals of programming. So I'm going to start by saving my file, Chapter 1 sample or whatever, and it automatically adds a .sb extension. So you have to save your file before you can run it. And when I say we give it instructions, so I might do something like first print my name and the date. whoops, I will probably do a lot of mess ups because I go from learning one language. This is something called internal. Try to say that if you want. Internal documentation or comments. They're not specific lines of code. But let's say that I want to print something to the screen. So I'm going to use the text window option and dot right line. And you see with Visual Small Basic is that it pops up our help for us. So it makes it really easy to learn. Hello, class. I'm Katie. And then I'll end that statement. And then if I wanted to write another statement, hear me using those keywords that we just learned. Programming is fun. I'm going to put this in my string literal that'll print it to the screen. And then I can save it again just as a precaution. When I want to run my program, I hit run, and my input, that my code that I wrote, went to the compiler, it interpreted it, and it gave me my output. I can't make this any bigger so you can see it, but it says hello Kate, or hello class, I'm Katie, programming is fun, and then press any key to continue. So those are the types of programs we'll work with in this class. So we have output that we throw out to the compiler, it makes our executable, it runs the program, and it ends. That is computer programming. So I hope you enjoy this class. I'm a minute and 30 over, so I'll end. But I know you'll enjoy this class. Just give it a shot. Make sure you listen to all these great videos that we'll make this semester, and do all your work, and you'll love programming. Have a great afternoon, evening, day. Have a great day. See ya.